Yes, hello everyone, welcome to my 3D meshing tutorial. Today we're going to mesh this part, then we're going to apply the forces. I will show you how to do that. First of all, you do the 3D part. These two holes will be where my part is fixed. So let's start. First of all, we have to click on the FEM 3D, the mesh generator. When we click on the mesh generator, we can modify the quality or the volume of our part. We can see the preview here. As you can see, there are more triangles, tetrahedrons on the surface of the holes. We can see we have 2597 tetrahedrons. So let's say yes and create. Now we have created our part meshed. Our first part is still existent, is here, but is hidden. So we are going to work only with this part. First of all, we need to block the nodes. To block the nodes, just a right click on the surface of one of our holes. So this one, we have detected the surface. We have this window that opens. For this one, we're going to block the displacement in X, Y, and Z. Okay. We can see the little cube that appears that tell us that the node is blocked. Then after that, the second hole. Everything is detected. The same window, and we block the displacement in X, Y, and Z. Okay. Then we're going to apply the forces on the other end of our part. So let me zoom in. We can detect directly the surface. We're going to apply a strength in newtons. We're going to start with 1 just to show what happens. Let's say okay. We can see an arrow pointing towards the Z plus Z1. And after that, we can select the part, right click again, editing, and compute the FEM. Now we are computing. The part has been computed. We can change the view, and we can see that we have already tensions on some of the parts. With the analysis, we can see how many von Misses we have on each triangle, on the vertices and inside, and we can see that the maximum is here. I'm going to switch back to my other window. If I double click on the part, we can see I use steel with the E modulus, Poisson, density, and elastic limit. We can always modify it. Right click on the name, and we can use a material. Or we can directly introduce our own material and save it on the library. The FEM meshing is of course in our software tetrahedrons. We can use linear analysis or nonlinear. For this example, I will only be using linear analysis. We can then display the results. If I go to a 2D window, we can see that the results are the following, and the 3D is here. So with 1 Newton is not enough to go over the elastic limit, but we're going to try now to make some more forces to modify it. So right click again. We can see we have Z1. This time I'm going to put 100. Okay, and the same. Apply, editing, compute FEM is going to take some more time. See the colors, and we can see the colors are going to get brighter and brighter. We click on analysis and we can see the von Mises are higher than before. Let's really modify this part. I can click again here, the same, but this time we can put 5,000 to see really a modification on the part. Here is it on this view. Click it again, right click, editing, compute, and we can see it has moved. So the part is no longer straight. And the forces are much higher than before. If we take away another window, we can see everything has been modified, and now the piece is at a breaking point because we are over the elastic limit. If this part is not the part we would like to modify, we can always edit. We can always, edit the object, the drawing lines, so we can see now the real object that appeared. I can go to the 2D window, modify the size of the holes, and even move the entity. We'll put it right here, close the window, update it, and then update my meshing, and we can see everything has been updated. You can see now that the strongest von Mises are on this hole and not on this one anymore. Of course, everything has been modified. Thank you to have followed this first part, and see you again for another tutorial.